Regardless of the competitive structure of an electricity market and whom the system operator works for, the system operator tries to schedule generators to meet forecasted demand in such a way as to minimize the total cost of the required generation. This scheduling is generally accomplished through what is known as economic dispatch. Economic dispatch involves determining a demand curve from the forecasted load, a supply curve from the prices that generators are willing to generate electricity for, and a set of market clearing prices that the demand and supply curves indicate will result in generation meeting demand as it varies throughout the day. Let's start with how the demand curve is created from an hourly forecast of the load curve for a day. For each hour of the day in this forecast, there is a predicted level of power that will be demanded as expressed in megawatts. Ignoring for the moment exactly when during the day that forecasted level of power will be demanded, reorder the different levels of demand from least to most, and then rotate the monotonically increasing graph 90 degrees clockwise. The x-axis along this new graph increases left to right from minimum to maximum level of power generation that will be required during the day. Note that the minimum power generation level is the level that will be required throughout the full 24-hour period, and so is the base load level. And note that the maximum power generation is the most power that will be required within any 1 hour during the day, and so is the peak load level. Consequently, the y-axis on this graph is the number of hours in a day that a particular level of power will be required, rising in hourly bins from 1 hour to 24 hours. At this point then, we have the quantity that will be demanded for different fractions of the day, but we don't yet have any information on the price of electricity. The price information comes from the generators. The generators provide two pieces of information to the system operator. These are the amount of power they can provide on an hourly basis and the price that they're willing to sell all that power for on an hourly basis. So think of each generator as a square. The width of this square is the amount of power the generator is offering to generate per hour as measured in megawatts. The height of the square, on the other hand, is the price that they're willing to sell the electric power for on an hourly basis. So the vertical dimension of the block is measured in dollars per megawatt hour. The system operator arranges the generator squares from lowest to highest price. So while the width of any square or the offered power capacity of any generator varies in this lineup, the height of the square, or the price that the generator is willing to generate electricity for, rises monotonically from left to right. This result then is a supply curve in that it indicates the cumulative generation capacity available during the day at each level of offered prices. Now, superimpose the demand for power for the different fractions of the day on top of the supply curve. With the price information from the supply curve, it's tempting to think of the intersection between the supply curve and the demand for power curve as the market clearing price for electricity. However, the demand for power curve is not a simple demand curve. It reflects the increasing levels of power that will need to be met for shorter and shorter fractions of the day. For example, a vertical line extending from the lowest level of power that will be demanded down to the supply curve indicates the number of available generators that will need to be brought online to collectively provide the level of generation needed to meet baseload demand. And a horizontal line extending from this baseload level on the supply curve to the y-axis gives the minimum price electricity will need to be to get these generators to produce this level of power throughout the day. The same process is used to determine the price that electricity will need to bring on additional generators to provide the higher levels of power required over shorter fractions of the day, with the price of electricity being highest during the 1 hour in the day when power demand will peak. The price is highest in this hour because the most expensive plant will need to be brought online to raise the cumulative level of power generation to the peak level being demanded. A couple of things to note at this point. First, only the generators or suppliers set the wholesale price of electricity. Buyers of wholesale electricity are price takers. Second, by using generators in the order from lowest to highest cost, the system operator managing the economic dispatch ensures that the wholesale electricity price is the lowest possible price given the prices demanded by the available electric generators. Third, the last and most expensive generator that the system operator needs to draw upon to meet a given level of demand sets the price for electricity that all other lower cost generators needed to meet demand will receive. So, as the price of electricity rises above the price that a lower cost generator is selling electricity for, that generator's profit increases, reaching a maximum at peak load when the electricity price is highest. Finally, only those generators that cost the same as or less than the cost of the most expensive generator needed to meet demand are used. Higher cost generators are not used and must wait for another day when demand may get so high as to need them as well. Through this system of economic dispatch, then, the system operator is able to identify which generators they are going to need to bring online for what fraction of the day to meet the day's various levels of power demand at the lowest possible total cost for generation. The only thing that remains to be determined is when during the day the different plants will need to run. This is accomplished by assigning the appropriate clearing prices to each predicted level of power demand and then using these power demand levels to project the prices onto the forecasted load curve. With this information then, the system operator can let each of the generators that will be needed to supply power that day when during the day the generators will need to be running.